Right, okay. Question 1, a nice bit of core 2. The polynomial is given by that stuff. Show that x plus 1 is a factor of f of x. I think we've already done this. Why are we laughing? Oh, I see. Good. Right. Oh, I did knock that out. I never do. So if x plus 1 is a factor, that means f of minus 1 should be equal to 0, shouldn't it? So we're going to try f of minus 1, see what happens. Always exciting. Minus 1 cubed, plus 6 lots of minus 1 squared, plus minus 1 minus 4, gives us minus 1. We've been talking about this stuff with checking and get your calculator right on this. Plus 6, minus 1 minus 4. Oh, how reassuring. That is 0. Therefore, x plus 1 is a factor. Note that you could have done long division here and shown that when you did long division your remainder was 0. That's an awful lot of work for 1 mark. So that's all they really wanted. Part B. Hence find the exact roots of the equation. What does the word exact in there give me a clue as to what's going to happen? What do we think? I don't know, because I've not done this yet. But reading the word exact suggests to me that we're going to get answers in third form. Because if they weren't going to be third form answers, they may have just said give the roots, because you would have given them exact naturally. The reason they're saying exact is they don't want you to give a decimal answer. So let's work this through. We believe that x plus 1 is a factor, so that means x cubed plus 6x squared plus x minus 4 is x plus 1 times something. The something, as we've just done when we went through the other exam, was x squared there, minus 4 and plus 1, so that must be a minus 4 at the end. To get 6x squared, well, 6x squared comes from doing 1 times x squared plus whatever is there, so that has to be a plus 5. Let's check that that works. We've got plus 1x there. That gives us plus 5x minus 4x is plus 1x to the right. Exact roots. Does this factorise? It doesn't, does it? Because it would need to be minus 4 and plus 1, which couldn't combine to give us a plus 5. So, one of the roots is x minus 1. The other root is when x squared plus 5x minus 4 equals 0. And now we can choose our method for this. You might want to do computing the square, or you might want to use the quadratic formula. X is minus b plus or minus the square root of, that's supposed to be plus there, of b squared minus 4ac, all divided by 2a, which gives us minus 5 plus or minus the square root of, what we've got there, 25 plus 16, so 41 over 2. And so the exact roots are x equals minus 1, x equals minus 5 minus root 41, all divided by 2, x equals minus 5 plus root 41 divided by 2, and there we go. Have to be an exact form, so you have to have them in thirds. 41 doesn't cancel down at all. So that's it.
What do you mark the root in decimal?
I'm going to say 2. Okay. Right. Jenny and Omar are each allowed 2 attempts at a high jump. I was middle school high jump champion. I in fact held the record in my middle school for the high jump for a little while. Just thought I'd share that with you. The probability that Jenny will succeed on her first attempt is 0.6. If she fails on her first attempt, the probability she will succeed on her second attempt is 0.7. Calculate the probability that she will succeed. Okay? Well, the probability that she... What can we do? Do you want to draw a tree diagram, or should we draw a tree diagram? She has a first attempt, and she either succeeds or not succeeds. So I'm using S and not S. I'm not sure it's the right notation to use. Probability that she will succeed on her first attempt is 0.6, so this must be 0.4. If she fails on her first attempt, the probability she will succeed on the second is 0.7. Consequently, that must be 0.3. Find the probability that she will succeed. Well, we find the numbers at the end of these branches, don't we? That's 0.6 for succeeding the first time. Here we've got 0.28 for her succeeding the second time. And here we've got 0.12 for her failing and then failing again. And so we could do this one of two ways, couldn't we? The probability that she succeeds is 1 minus the probability that she fails. So we could do 1 minus 0.12. Or we could just add the two ways that she succeeds together. So the probability that she succeeds equals 0.6 plus 0.28, which is 0.88. Alternatively, we could have done 1 minus 0.12, 0.88, and that would have been just as good. Right, part B. The probability that Omar will succeed in his first attempt is P. If he fails in his first attempt, the probability that he will succeed in his second attempt is also P. Oh. The probability that he succeeds is 0.51. Find P. Well, I think in this way of thinking about this one comes a neat little hint as to how we might do this question. I think that's probably the easiest way of thinking about it. The probability that he succeeds is 0.51. That's overall, isn't it? So the probability that he fails is .49, because he either succeeds overall or he fails. Now, the only way that he would fail overall is by failing twice. And the probability that if he succeeds on any attempt is P. What's the probability of him failing on any attempt? It's 1 minus P. So actually this figure of 0.49 equals a failure followed by a failure. And I think that's probably the easiest way of doing this, because what we've got here is that 0.49 is 1 minus P all squared, 2 successive failures. If we square root 0.49, we get 0.7 as being 1 minus P, and so P is 0.3, and that would be the right answer. If we feel we need to check this through and make sure it makes sense of what we did in the first part, we could go back and say this is 0.3 and 0.7. That's a succeed, that's a fail. This is 0.3, this is 0.7. And look, if we do 0.3, 0.7 times 0.3, we get 0.51, exactly as we thought. There we go. Great work, and that's maths.